Good afternoon. Let's look at a practice problem to get ready for an exam or just to practice circuit techniques in general. The first problem that we'll look at is problem number 1 on an old exam from the summer of 2007. This problem says if the power absorbed in R sub 2, which is this particular resistor or this resistor, if the power absorbed there is 32 watts, find this particular current I sub S, which is a little bit different in terms of how you're used to thinking of these problems. And if you don't really know where to start, what you might do is say, how would I solve this if I sub S was given? If I sub S was given, then you would say, oh, there's probably my node that I'm interested in, because hopefully now you understand that these three resistors in series are effectively then in parallel with this R4 resistor, and they all share this common node that I've highlighted in red. If we label that node as V1, if we could find V1, then we would find the current, let's say down here, which is I sub 4, and then if we knew V1, we could sum these three resistors and find I sub 2, and given I sub 2 and I sub 4 by KCL, we could actually find I sub S. So that's not a bad thought process. We just have to change it a little bit, because we've been given something a little different, and that is the power absorbed by this resistor R sub 2. But if you remember then a little bit about the power of R sub 2, that's just the voltage across R sub 2 times the current through R sub 2. Or if we don't know the voltage, but we really want to know this current I sub 2. So this is now voltage across R sub 2, I sub 2, in terms of the currents that have been defined. And we know that V sub R sub 2 is actually R sub 2 I sub 2, and we then can, or have already now, re-derived this power relationship for a resistor. Now that we have that, we can use that information to actually solve for one of these currents that we want. We're trying to find a current I sub 2 and a current I sub 4. Well, we know the power. We were given that. That's 32, and that's equal to R sub 2, which we know. The only unknown in this equation is the current I sub 2. And now that we have everything else specified, we can now find I sub 2. I sub 2 squared is 32 over 2, which is 16. And that now allows us to say that the current I sub 2 is now the square root of 16, or 4 amps. That's the current coming down through that resistor R sub 2. That current is the same as this current, and that's the same as this current. Those three resistors, R sub 1, R sub 2, and R sub 3, are in series. They share the same current, which means that we can actually find the voltage dropped across all three of those. And if we can find the voltage dropped across those, let me clean this up a little bit, or try to. Now that we have the current known, I sub 2, we can now find this voltage drop, V sub R sub 1. We know V sub 2, and maybe I should just call this V sub 3 across that resistor. Once we know that, voltage drop here across R sub 1, across R sub 2, and across R sub 3, those by KVL actually give us the voltage drop V sub 4 across R sub 4, but V sub 4 is just V1, and we said, oh, if we could find V1, we can obtain I sub 4, and once we have I sub 4 and I sub 2, by KCL we know I sub S. That's the strategy now that we're going to employ. V sub R sub 2 then, V sub R sub 1 is just R sub 1 times I sub 2. R sub 1 is 1. I sub 2 we just calculated to be 4. And we now know that V sub R sub 1, or V sub 1, is 4 volts. V sub 2 we haven't calculated, but we can. That's the drop across R sub 2. That resistor is 2, the current is 4, and we now have 8 volts dropped across V sub 2. Finally, V sub 3 is the same current times R sub 3. The R sub 3 is 3, the current is 4, we have 12 volts. We can now write this KVL relationship that we wanted. I should continue to call that V sub R sub 1 because we've already defined one capital V sub 1. I'm sorry for that. But the KVL that we want, we're going to start at that lower left-hand corner and work our way around. KVL now is minus V sub 4 plus V sub R sub 1 plus V sub 2 plus V sub 3 is equal to 0. Or we can now see that V sub 4, solving for that expression, is V sub R sub 1 plus V sub 2 plus V sub 3, and that's now 4 plus 8 plus 12, or 24 volts. And V sub 4 is just that one quantity that we said, oh, if we knew that at the beginning, we could solve for everything. Now we know what V1 is. That's 24 volts. From Ohm's law, we know what I sub 4 is. That's V1 over R sub 4, or that's 24 divided by, and R sub 4 was actually 4, and consequently, I sub 4 is then 6 amps. The only thing remaining to determine the quantity that we were asked to find, which was I sub S, and that's this particular current source value, we can now find that by applying KCL at that node that we had highlighted in red and now, or circled in red. Now we've highlighted in blue. It looks black now with the circle. If we now apply KCL at that top node, we have the input current coming in, I sub S to that node, I sub 4 going out, and I sub 2 also going out. We just calculated I sub 4, that was 6 amps. I sub 2 we calculated to be 4 amps. And now we know what the source current actually is. It's 10 amps. And that's really what we needed to find for this particular problem.